Hello, I'm Zura Zaman, your instructor for Algorithms course. Today, I want to cover binary search. So, binary search is a comprehensible algorithm. How it is comprehensible, let me show you with an example. So, suppose you are a teacher and you have a group of 300 students in front of you learning from you. Now, you have their exam result paper in front of you and in order, alphabetized order, because it is sorted so that you can be easier to be spreaded in the students. So, let's say this is the exam result paper. The first one is for Anni, second one is for Aisha, then is Bill, then so on. So let's say now a student named Zubair comes up to you for his paper bag. Now, will you go from Anni to Aisha to Bill to Karen to Sarah and then to Zubair? No, you probably wouldn't like it that way. So to make it more easier, you probably would go roughly halfway through it. Let's say you will make the paper cut in half. That is, you will first take the first stack of the paper and then you will take the other stack of the paper. To make it more easier, then in the first stack of the paper, you probably found that the last name is of Karen. So you know that the name Zubair comes after the name Karen in alphabetized order. So you basically avoid the first stack of the paper now, and then you go for the next step of the paper, like your own little stack. In that stack of the paper, you choose the midpoint, like where you get the name Sarah. So then you say to yourself, is Zubair come before Sarah or after Sarah? So you know that Zubair comes after Sarah, so you repeat that first step process and until you get the name of Zubair, or until you find out that the Zubair's name is not present in the class. So basically, this is the basics of binary search algorithm as well. So now let's see an example using an integer array. Let's say this is an integer value array. Here there is 11 integer values. Now let's say you are looking for the value 13 inside this array. So what you gonna do is you need to in case of binary search, you need to make it halfway. That is, you need to make the array crossed or halved in number, so that when you make the array half, then you get the midpoint, that is the mid value 20. So after getting the mid value 20, you will compare it with the search value, which is 13. Like as I have given you the example, the practical example before. So when you compare it with the search value 13, you see that 13 is actually less than 20. Always remember that in binary search algorithm, the array always need to be sorted, which is very important for binary search. You can't complete a binary search algorithm in case of an unsorted array. So when you compare that the value 13 is less than the value 20, that is the midpoint, so you basically know that the value 13 is in the left side of the array rather than being in the right side. So what you're gonna do is you can easily make the right side of the array cut down. That is, you don't need this array anymore. You now compare the left side of the array to find out the search value 13 inside it. So now when you compare the left side of the array, you again repeat the same process and find out the midpoint, which is 4. Now you compare it again with the search value, that is 13. Now you can see that 13 is actually greater than 4, right? So what now you gonna do is you need to look for the value 13 in the right side of the array, because yes, 13 is greater than 4. So when you look for the value 13 in the right side of the array, you repeat the process as we said earlier in the step 1. In this procedure, you either found the value 13 in the total array, or you can also not find the value 13 in the total array. And in this way, the searching algorithm ends. But now the question is, how fast is this binary search algorithm? Now the question is, how fast is this binary search algorithm? The binary search in the binary search algorithm, let's say we take n number of elements, that is, the space is n numbers, and when we search in the first comparison, in just one comparison, the n number of elements is cut down to n over 2, that is n by 2, and in the second comparison, it is cut down to n by 4. In this way, this comparison ends at 1 until you find goes to the value 1. So in case of worst case, that is when you can't find the search value inside the whole array, that in that time, how we determine? We determine the value by dividing the n number of elements by 2 and reaching it to the 1. In this way, binary search algorithm finds out it. So what it is actually the logarithmic function, that is log base 2 number of n expressions. Now if you don't remember your logarithmic math that you read before in your intermediate, so now I will explain you shortly. So log base 2n means, log base 2n or log n means n equals to 1 into 2 to the power k iterations, where actually k is where actually k means 1 into 2 1 multiplied by 2 to reach up to n number of iterations. So basically now you understand that binary search is actually a log n based expression or log n based iteration. So I hope you understood what binary search is, and you have understood that binary search is actually faster than linear search, as I have read you in the before class. So I hope you enjoyed the class today, and if you have any question, you can ask me in the discussion forum. Thank you.